Hi, good morning, one and all. I am Kundana from CSE, Department of CSE, from Sri Vishnu Educational Society College for Women, Bhimvaram, under the guidance of Dr. M. Prasad, Associate Professor, Department of CSE, Sri Vishnu Educational College for Women, Bhimvaram. My topic is singly linked list. My problem statement is write a C program to implement and manage a singly linked list using referential structures. The program should provide the following functionalities. First thing is create a linked list by adding new nodes at first beginning, second ending, third at a specific position, and display the contents of linked list. Third one is search for a specific value in list and indicate whether it exists or not. Coming to fourth one is delete nodes from the linked list, by position. Coming to last but not least, exit the program whenever the user chooses to terminate. So let us come to the program. Hash include less than stdio.h greater than. It is a including file. It includes stdio to our program header file. Stdio is nothing but a header file. Hash include less than stdlib.h greater than. It is also a linking instruction. Stdlib is also a header file. Let us come to our C program. First, we want to define a node structure so that I'm using a structure. So struct strcut and I'm keeping the structure name as node. In that I want to store a data and a structure. So it is int data semicolon and struct node asterisk next semicolon. And now let us create a function to a new node. Struct node asterisk create node int data. So struct node asterisk new node equal to struct node asterisk malloc of size of struct of node. So I am storing new data in the place of data and the structure as null, so that initially we want to store initially we want to store data as data and structure as null, so that I am using new node pointer arrow mark. It is nothing but an arrow mark. It's a pointer operator is data and new node of next is null. Next is nothing but we uh, declared at a structure in structure, and returning new node. New node is nothing but again data and null. Okay. Next, coming to function to insert a new element at the beginning of the singly linked list. Void insert at first. It's a function so that we are using before the main. Void insert at first. Struct node asterisk head in data. Struct node asterisk new data is equal to create node of data, so that I am using a head and pointer head, so that I am using new node to next is initializing with head. Head is a pointer, right? So we are using asterisk head, and asterisk head is equal to new node. Next, coming to another function insert a new element at the end of the singly linked list. Void insert at end. Struct node asterisk asterisk head int data. Struct node asterisk new node is equal to create node of data. So coming to here, in the previous case we used it at beginning so that we uh, directly initialize it. But here we want to set up at end so that if asterisk head double equal to null means if the head value pointer value of head is double is null, then asterisk head is declared with a new node, and that's all. Struct node asterisk temp is another variable to store the head value, while temp arrow mark next not equal to null, temp equal to temp arrow mark next, temp arrow mark next double equal to new node. So this is if we are using temp as another keyword, not a keyword, sorry. We are initializing temp as an another variable and we are storing the address of head in that. While temp next not equal to null until the loop turns until the temp next comes to null. Temp is equal to temp arrow mark next and temp next is equal to new node. That like while loop rotates until temp next not equal to null. Function used to insert a new element at a specific position. So we want to the user want to give at a specific position, right? So I am using another function void insert at a position struct node double asterisk head int data int position. Struct node asterisk new node is equal to create node data. If position double equal to 0, insert at first head comma data means as in uh, beginning. If and struct node asterisk temp double equal to head. For int I equal to 0, temp not equal to null, and I less than position minus I plus plus. It's a loop so that while temp not equal to null and I less than position minus 1, okay, then we can store temp is equal to temp arrow next, and if temp double equal to null, printf position out of range. So our program is now some more completed so that we are using free new node equal arrow next is equal to temp arrow next is equal to new node. Okay, then another coming to delete a first node of the singly linked list. Void delete from first. Struct node double asterisk head. If head double equal to null, printf list is empty. Struct node temp is equal to asterisk head. Asterisk head is nothing but a pointer, and asterisk head is initialized with temp next. Then we want to free temp also. Then coming to delete a last node of a singly linked list, we are using another function void delete from end. New struct node as double asterisk head. If asterisk head double equal to 1, printf list is empty and return nothing. Struct node asterisk temp equal to a pointer head. If temp arrow next double equal to null, free of temp. Temp is variable we declared at first, right? And head is equal to null. While temp next not equal to null, we are using too many times. It's no problem to use a arrow mark two times in a condition. Temp is equal to temp arrow next, then free of temp next double equal to null. Write a function to delete a node at a specific position in the single linked list. Void delete at position. Struct node asterisk head int position. If head double equal to null, printf simply list is empty. Struct node asterisk temp is equal to asterisk head. If position double equal to 0, delete from first head. For int I equal to 0, temp not equal to null, and I less than position minus 1, I plus plus. Temp equal to temp arrow next. If temp double equal to null, and this is a symbol of or, temp arrow next double equal to null and temp double equal to null, printf position is out of range. Struct node asterisk next equal to temp next free temp next, and temp next is initialized with next. Function to print linked list. We initialized and declared right, but we want to print the linked list. Void print struct node asterisk head. Struct node asterisk temp is equal to head. While temp not equal to null, printf percentage d arrow temp data. Here percentage d is temp data. Temp is equal to temp next. Printf null. So we up to now we didn't initialize our main, right? So we are initializing the main. Int main parenthesis open parenthesis close flower braces open. First we used the structure, right? So that we are initializing struct node asterisk head equal to null. Insert at first ampersand head comma 10. We are giving head value as 10. Okay. Printf linked list after inserting the node 10 at the beginning. Print head. Then coming to linked list after inserting node, we are giving 20 at the end. Insert at end 20. Printf linked list after inserting the node 5 at the end. Insert at end. Coming to here we can see insert at end, giving ampersand head and int data. I think you are understanding. Okay. Insert at end, giving an value and int data type. Print head. Linked list after inserting node 30 at the end. Insert at end ampersand head and 30. Coming to insert at end. Insert at end, giving a structure and a data. I gave ampersand head there, and here the value of int data is 5. It will take and it will print. Then coming to inserting data of node 30 at the end. This is also at the same. Both are same. Linked list after inserting the node 15 at a position 2. So this is typically different because we want to give position also here. So insert at position, we'll go to the function insert at position, right? Here we are giving an structure and then data and position also. Position is second position, so I given here last so that it will print there. Linked list after deleting the first node. Here I am giving an only the structure, right? So here also I am giving only the structure, it will print. Linked list after deleting the last node. I am giving only here the address of head, right? Structure, right? So here also I am giving only structure. Okay, then coming to the last one, linked list after deleting the node at a position 1. Here I want to give the position also, so that let us check in the above case we given position or not. Let us check. Wait, see here, deleted position struct node double asterisk head and int position. I given position also there, so that it will print and finally return 0. Let us run it. See, you can give the correct. Okay, linked list after inserting the node 10 at the beginning, 10 arrow null. Linked list after inserting the node 20 at the end, 10 arrow 20 arrow null. Linked list after inserting node 5 at the end, 10 25. Linked list after inserting 30 at the end. I am giving it end only. 10 25 30. Linked list after inserting node 15 at position 2. See here. Here not the beginning, not the end. In the position 2. So that uh, it will came after 20. Linked list after deleting first node. I am deleting first node. So 10 will be deleted. So 20, 15, 5, 30 and null. Linked list after deleting last node. I am deleting last node. So that 30 will be disappear. 20, 15, 5 and null. Linked list after deleting the node at position on 1. I am deleting the position first of a linked list, so that the second one will be deleted. So 20 and 5 and null. So I hope you understand the singly linked list. Thank you.
Hello everyone. This is B. Likita Venkat Sahasri from CSE-B, currently pursuing first BTech first SEM in Sri Vishnu Engineering College for Women Autonomous Bhimavaram. This video is presented under the guidance of Dr. M. Prasad Sir, Associate Professor, Department of CSE, Sri Vishnu Engineering College for Women Autonomous Bhimavaram. Title: Minimum number of laptops required to perform overlapping jobs. Now let us look into the problem statement. Here the problem statement is to find minimum number of laptops required to perform overlapping jobs. There are n jobs and the start and finish time of the jobs are given in arrays start and end respectively. Each job requires one laptop and the laptops can't be shared. Find the minimum number of laptops required given that you can give your laptop to someone else when you are not doing your job. Now let us look into our program. Here our program is to calculate the minimum number of laptops required to perform overlapping jobs. At first we have to include the header file. So I have included the header file stdio.h. It is the standard input output header file. And going through the main, I have declared 4 variables n, m, I and z. Here m, I, z are the variables that are used for in the loops and n is the variable that holds the value of number of jobs. At first, we are scanning the n value from the user. After scanning the n value, I am declaring two arrays start of n and end of n. These two arrays stores the starting time and ending times of the jobs respectively. Here, for scanning the array elements, I am using the for loop. After scanning both the starting and ending times, I am using bubble sort. A bubble sort is applied to the start of array to arrange the jobs in ascending order of their starting times. While sorting the starting times, we also sort the ending times simultaneously to maintain the relationship between starting and ending times. Here in this sorting, we use a variable temp for swapping of the elements. And then after sorting, here I am using a counter variable laptops and assuming that we require a minimum of one laptop for performing these overlapping jobs. So I have initialized the counter variable laptops to 1 and another variable current end. Here I am initializing it to the end of the first job. And then for each subsequent job, if the first starting time of the job is less than the current end, it means the job overlaps with the currently running job. So, an additional laptop is required for this job. Hence, the counter variable laptops is incremented. Otherwise, if the starting time is greater than or equal to the current end time, it means the previous laptop is free. So we can update the current end to the end time of the current job to reuse the same laptop for performing the job. And after this loop continues until the condition fails. So after the loop ends, it prints the value as minimum number of laptops required. So our program displays the minimum number of laptops. So let us run the program. Now we have to enter the n value. I am giving n value as 3 and we have to give the starting values. I am giving as 1, 2, 3 and ending times as 2, 3, 4. So minimum number of laptops required is 1. After the finishing of first job, the laptop is free. Hence, we can reuse it for the second job. And after that, we can reuse it for the third job. Hence, we require only one laptop for this. Let us work on another example. Running it again, we have to enter the n value and then after giving the values, we require 3 laptops because the first job is unfinished and the second job is started. So there is no chance to reuse the same laptop, hence we require 3 laptops for this. I hope you understood this program. Thank you. Have a nice day.